Hey guys, welcome back to the shop. We got a new project that we're starting on. This is going to be a custom requested project for my friends Trent and Heath Potter. Trenton and Heath on YouTube. They are shoe cobblers. Had them in a couple of my videos where they have repaired my Thorogood boots. Recently, it was back in May, my wife and we took a trip up to Ohio, and along the way we stopped there in Columbia, Tennessee, and paid a visit there with Trenton and Heath. Trent was not there that day, it was the weekend, but I did get to meet Heath, spoke with him, and when I was dropping my boots off, he had a project, which is kind of what you're seeing right here, with these shoe anvils. He asked me, he says, hey, are you able to modify a couple of these guys here with a steel plate, something, a larger work surface instead of this actual work surface right here? So we were checking it out, and he says, I just need some kind of steel plate that these, the shank of it will fit down inside. I don't know what you would call that, the tube where this goes in, it's got a taper, and where they place the shoe or the boot on there to do their work on the soles there, doing their hammering. So they seem to have a lot of applications where they're using these already, because this is what they have. These are available in a lot of places, older antique type tools, but they're just using the surface and they're putting soles, such as they make a lot of sandals there. So they're just using this as a flat work surface, and that's what they would like, is to have a couple of these. I mean, they have a lot of these, so they would actually like to have a couple that, instead of having this shoe pattern there, they just wanted a nice flat work surface that they could work on. So that's exactly what we're doing. I had the local welding shop cut these out for me. These are 8" by 8" square, and I chose 3/8 thick plate. And all we're going to do is simply cut this off, just right about in there. We're just going to cut that off. Probably just going to use a cutoff disc or a cutoff wheel to cut these things off. These are cast iron, and once we cut them off, we're going to put them on there. I'm going to clean the plate, get rid of the mill scale where we're going to bond it to there, but I'm going to braze them on there, okay? Since we're going with cast iron and steel, a good braze should have a very good strong bond and never have any worry of this thing coming off. They're not going to be using this like a conventional anvil, so you don't have to, don't sit there and think that they're going to be over here smashing this with hammers on the side. They're just simply setting soles and whatever materials that they're using in the shop. They just need a nice flat surface that they can come up and do their work, with their hammers there. So decided that we're going to go ahead and make 2 of them right now. I'm going to get these 2 made and send them down there, and they're going to put them to work and see what they like. And if they like these, I've got 2 more of these because I brought 4 of them home. And if they work good, we'll go ahead and make them 2 more, so they'll have 4 of them in the shop there. So that's the project that we're going to get started on today. So it is time to go over there, set these up in the vise, or however we're going to do it, and get these guys cut off. All right? I think clamping in the vise is going to work. We're going to use the 6" Metabo. And I thought, since we've got quite a bit of cutting here to do, I'm going to try 2 different wheels. So I normally run these Metabo cut-off disc. I like them because they're really thin. I think this is about as thin as you can get it. They're 40 thousandths thick. All right, so a little bit less material that you're having to cut through whenever you're using this. I've also got these Osborne wheels. This is the A60. They're a little bit thicker at 45 thousandths. Maybe a little bit newer than what these are right here. I've had these for a long time, but I don't know. This one's also made in Germany, and I would just like to compare the cut quality or whatever and see if there's any difference. So we'll use the Metabo for one and use the Osborne for the other one. All right, there we go. I got a little bit of a kerf on it, so I'll just have to dress it. Probably just go over the belt sander, just try to square it up as close as we can. But that wasn't too bad at all. It worked out pretty good. Probably can't hear me very well with the face shield down. I'll try not to get so much of an angle on the next one there, but go ahead and swap out this wheel. We're going to take the Metabo slicer off, and we'll put the Osborne on there. We're going to use the Osborne on this one here. Well, all I got to say is both wheels worked, and they both worked good. So I don't know if one outperformed the other, but they both get the job done. We got these cleaned up good. What you want to do anytime you're going to be welding some cast iron, anything for that matter, but especially cast, is go ahead and clean the material good. Get rid of any oxidation or paint, any crud that might be around the weld zone. The best thing to do is just take it down to bare metal, either wire brush or use a grinder like I did, flap disc, to get sort of the scale off the outside of the cast iron there and get it down to some clean, fresh iron. So, and I just wanted to wire brush it to give it a nice clean look, you know, whenever we're done. And when we're done brazing, you know, I'll wire brush it to kind of get rid of any of the flux that's on there. So we just scribed some center points on the plates right here. So whenever we're done dressing the mill scale off, I'll put those marks back on there so we can see where we need to go. But we're also going to be marking these just kind of like so. What I want to do is we're going to have to use an actual grinding wheel, not the flap disc, and I want to just cut the mill scale off that. I don't want to grind into it, remove a bunch of metal, but that stuff is so hard that a regular flap disc is going to have a hard time getting all that off, because all you're really doing is polishing it. So I'm just going to kind of do this right here. Just kind of get a general idea of where I want the mill scale to be removed from. This isn't anything that's super critical or accurate, but I don't want to be doing the whole thing. So we'll just come in here and just kind of remove the mill scale from those areas using a grinding wheel. So I'll put a used grinding wheel on here. You already got a nice rounded edge on there. This is where this is going to work better versus a brand new grinding wheel that's got a sharp corner on there. I think that'll work good. I'm gonna go ahead and put the flap disc back on there now and just come in here and just polish that down a little bit. But that should be, we're just about ready to get to our brazing. So I'm set up over here on the positioner. What I want to do is get it tacked in. We're going to be using the TIG welder there, the Everlast. Do a TIG braze, but only for tack. And I want to get 4 tacks on there so that that thing will hold in place and not move around. Because I am going to braze it with the torch and a conventional brazing rod to finish it out. I don't want to TIG braze the whole thing. I'd rather do it with conventional methods because that's what I'm comfortable with. I know it'll be a nice strong bond whenever we do that. I'm not trying to fuse it like arc welding. We're just trying to melt the brazing rod and it flow into both the steel and the cast iron. This is what I'm doing here. I'm just trying to get a little extra heat in there and let that brazing rod flow. Use the argon to help protect it, cool it down there right at the end. And it should have very minimal lift on it. Yep, very minimal, so that's pretty good right there. We'll go on the back side and then we'll do the 2 sides. Try to get a lot of the heat in the steel, and then the brazing rod flows in there really well to it, and then work it over against the cast iron. Once the cast iron gets hot, that brazing rod flows over into it and bonds. Using the torch here to do the heating like you would with a acetylene torch. Just trying to get it hot. I've got the amperage range set so that I can engage it slowly and then press the pedal all the way down to be at my maximum heat that I want it to be at. Seems to be working pretty good like that. One reason to do that as well is so that you can just push it all the way down and fully support yourself instead of trying to stay on that balance position of that foot pedal. I just put a piece of steel in the vise right there to get my heat range set the way I wanted. And then once I was there, come over here and do this. So there's our TIG braze tacked together part. Okay. So I'm not concerned about, whenever we braze this, it's going to make this plate warp and draw that way. Not concerned about that because of the way this is being used. It's not going to hurt it one way or the other if it's completely flat or if it's got a little bit of a bow to it. So we're just going to braze it and let it do its thing, because I want to set this up on some fire brick or some heat insulators there so that when I'm heating this up and doing the braze, everything underneath it isn't sucking that heat directly out of it at the same time. So we're going to get it set up for brazing now. I'll bring you back when I'm ready. All right, we're ready to braze it. I'm going to go ahead and braze it right here. I actually like it up like this, where I'm not having to like bend over to see it. I don't have to bend over right here. So we've got it on these insulating tiles right here, so it should block the heat from going down. What I'm going to do is go ahead and preheat this, but I'm going to use the weed burner here, the propane weed burner, to try to get this thing nice and hot before we get in there and start doing our brazing. Okay, so here we go. Sometimes it don't want to light. I guess you got to do it that way. I was going to turn this on too. We got our fume extractor. We're going to be running that. I think we got her bonded in there good. We've got our first one finished up. I'm happy with the way it flowed in there. I think that's going to be a nice strong bond on that. I don't see that ever breaking loose. I mean, it's possible it could happen, but I just don't think it's going to. I think that's really good right there where it's at. So I'm going to go ahead and just move this one off out of the way. Our little cheap weed burner did pretty good on heating that thing up. All right, so number 2. By the way, these are heat insulating tiles that were used. It was the same material, the same tiles that were used on the spaceships for NASA. Pretty cool. I had someone give me those. I want to say, I can't remember who it was now, but there's one of them right there. There's even some numbers on there. Some type, I forget what it's called, some type of silica is what it is, but pretty cool. It works great for stuff like this. All right, we got number 2 done. I think it flowed in a little bit better for me. I had a little bit better control over the filler rod on this one here, but I've been looking at it all the way around. I think we are bonded well, both on the cast iron and the steel. So those 2 guys are done. Other than cleaning it up, I'm gonna let them cool, and I want to knock all that flux off of there, probably wire brush it, make it look presentable. Other than that, it's going to be done. All right, guys, this job is all finished up. I went ahead and got them cleaned real well. I used my needle scaler to help knock off all that glass-like flux that dries up onto the material there once it cools down. So use a needle scaler to kind of get that cleaned up, wire brush, and wire brushed it all. And that's where we're at right there, okay? I am happy with the results. I wish that I would have made the, the build up there a little bit prettier, a little bit more uniform, but that's a good job, and it's going to hold it's going to do its job. It's going to hold nice and strong and give them good service. I have no doubt there. So now it's guaranteed that you can go down to the comment section below, especially after this video has been out for a little while, and you're going to be reading, or you will read, a lot of the could have, should have, would have comments on other techniques that I should have used rather than brazing. It's guaranteed it's going to be there, because this, anytime I've learned doing YouTube videos, anytime you show brazing, you have a lot of people that are a lot smarter than you and think that your technique that you're using, your old school, old world technique is nowhere near superior as today's modern TIG brazing techniques that some folks like to use. So my opinion about brazing, I believe that you get a superior bond whenever you're brazing, like I showed you, using a acetylene torch and a brazing rod, and you do the proper cleaning of the material to make sure you have no contaminants there. You do your preheat, and once you get in there and you start flowing this together, you're going to get an excellent bond versus an arc weld. That's what some people will say, is that I should have just used a nickel rod and welded it together. It's just as strong. Well, I completely disagree with that. A nickel rod, if you're doing a nickel rod with arc welding, it will hold. And it would probably hold for what it is they're doing. Although I don't like the leverage. This is going to be used as an anvil, not a heavy duty anvil. You're not over here like a blacksmith. It's just going to be light duty leather work, you know. But with the leverage on there, I believe that it's possible that if you arc welded it with a nickel rod, you're going to have a potential of it cracking and breaking out of the cast iron. When you're brazing, that's different. You're not fusing into the metal. You're only heating it up to a certain point where the material, the brass, the brazing material, flows in there and bonds to both the cast and the steel. So I just feel that brazing is going to give you a superior bond to dissimilar metals versus an arc welding procedure. Now you'll also have people that say you should have just TIG brazed it. That's how we tacked it on there. Whenever, if you might remember, I had my TIG torch. There's going to be people thinking that I wasted my time doing this and I should have just TIG brazed the whole thing. That too, I don't think is superior as the true brazing method that I showed right here. I think that in today's day, with social media and Instagram, there's a lot of hype out there, and people feeling pressured that every single weld has to be absolutely beautiful, that looks like stacked dimes and looks like a rainbow going across there. And in reality, this kind of work is performed every single day all over the world that you never see. That works. It's tried and true, and it gets the job done. It gets people back in service. That's the stuff that you don't see. That's not out there on Instagram. But my opinion is that this is going to be a superior bonding procedure versus an arc weld, whether you're going to use a TIG, a MIG, or a stick welder. I wouldn't recommend MIG any way you look at it. It's not going to hold very well. It's not going to be near as strong. So brazing it is for me. That's what I like. And you know what? The proof is out there in the books. If you pick up some books, especially some of the older welding books, and you read about this kind of stuff, you'll see for yourself. Now, saying that, I would love to see some testing, you know, somebody that has the equipment that you can actually put proper testing to. Somebody like maybe Jason over at Fireball Tool, you know, maybe he can do something one day where he, you know, since he's a welder, maybe he can do some brazing, TIG brazing, and nickel rod welding for a piece of cast iron to steel, and put it to a test and see what kind of pressure that it can withstand before it gets to its yield point. You know, that'd be an interesting test I'd like to see. I'd love to see proof of that, you know, rather than just people, you know, typing in a comment saying that, oh, you should have done this, it's stronger. No, I know it's strong, and I know that this is going to work really well. Like I said, this is not some heavy duty anvil that they're going to be hammering on with a ball peen hammer and a piece of steel. This is just simply a flat work surface is all it is, so that they can lay some leather up here. You know, he showed me a sole for a sandal where they have to get in there and do some nailing on there. And that's all they needed, just a larger work surface for them to work on versus the other style. Like this right here, this is what we cut off, you know. That's what he was showing me. They just needed more work surface. So what I had proposed when we talked about this is that he said he'd like to have 4 of them. I said, well, let's go ahead and make 2 and prove it and make sure that it's going to work, and that maybe, you know, this is the size that he told me he wanted, 8" by 8", you know, and I put some radiuses on there. So I'm going to send these up there so that they can put some time on them and see if they like them, and if they like that size, if we need to modify it or whatever, we certainly will. And I've got 2 more of these. We'll do the same thing. I'll end up cutting them off and, you know, brazing them to a piece of steel. So y'all be sure to check out Trenton and Heath's YouTube channel, Potters and Sons. They are a couple of Southern gentlemen, really good people, and they do excellent work. They have some great videos, and we're all definitely learning a lot more about the shoe and boot repair business by watching some of their videos. So I'm going to get these boxed up and sent up there to Tennessee, and I hope you guys enjoyed the project, and we'll see you later.